Download this code from codegive.com, link in the description below. Troubleshooting looping commands causes client request loop error 81 on GitHub, a detailed guide. This error, looping commands causes client request loop error 81, on GitHub usually arises from misconfigured GitHub Actions workflows that unintentionally trigger themselves recursively, creating an infinite loop. This can quickly consume your action minutes and potentially lead to resource exhaustion. Here's a comprehensive guide to understanding, identifying, and resolving this issue. 1. Understanding the root cause, recursive workflow triggers. The core problem lies in a workflow triggering another workflow, which in turn triggers the original workflow again, and so on. This forms a loop. Let's illustrate with an example. Imagine you have two workflows. Workflow A triggers on push events to the main branch. Workflow B triggers on pull requests to the main branch and, as part of its job, pushes changes to the main branch. Here's how the loop can occur. 1. A developer pushes a change to main. 2. Workflow A starts, triggered by the push to main. 3. Workflow A completes, or even during its execution, and doesn't directly contribute to the loop. The potential issue is how other workflows react to Workflow A's changes. 4. Workflow B starts, triggered by the pull request to main, which now contains the changes from the first push. 5. Workflow B modifies files and pushes a commit to main. This is the critical step that creates the loop. 6. Workflow A is triggered again because of the push made by Workflow B. 7. This process repeats infinitely, leading to the looping commands causes client request loop error 81. The error message itself is often a symptom, not the cause. It indicates GitHub's attempt to break the loop after a certain number of iterations, preventing a complete resource drain. 2. Identifying the culprit, workflow analysis and debugging. Pinpointing the specific workflow responsible for the loop requires careful analysis. Here's a systematic approach. Examine recent workflow runs GitHub Actions tab go to the Actions tab of your repository. Recent runs review the list of recent workflow runs. Look for workflows that have been triggered repeatedly in quick succession, especially if they've resulted in failures with the looping commands error. Check triggering events. Carefully inspect the triggering events for each workflow. Are any of them triggered by pushes or pull requests that are being generated programmatically by other workflows? Workflow duration. Note the duration of the failing workflow runs. Extremely short runtimes can also be a clue, indicating that the workflow is being rapidly triggered and terminated before it can complete. Review workflow definitions, .github/workflows/.yml. On triggers. Pay close attention to the on section of each workflow file. Identify any workflows that trigger on push or pull _request events. These are the most likely candidates for involvement in a loop. Uses actions. Examine the actions being used in each workflow. Uses. Some actions might automatically create commits or push changes to the repository, even if it's not immediately obvious from their names. Refer to the actions documentation. Run commands. Inspect the run commands within each workflow. Look for commands that might be pushing changes back to the repository, such as git commit and git push. Even seemingly innocuous commands can trigger workflow runs if they lead to repository modifications. *github_token usage. When using github_token for pushing, consider its permissions. By default, it has read and write access to the repository. This is what allows workflows to push changes, but it's also what can create loops. Restricting the token's permissions may help in some scenarios. See mitigation strategies below. Examine your GitHub apps and bots. Check for automated commits. Do you have any GitHub apps or bots that are configured to automatically make commits or push changes to the repository based on certain events? These can inadvertently trigger workflows. Review app permissions. If you find such apps or bots, carefully review their permissions to ensure they aren't excessively broad and that they're only performing the necessary actions. Logs. Although the workflow might fail quickly, check the logs. There might be some specific actions or steps that point to the cause before the termination. 3. Code examples and scenarios. Here are some common scenarios and code examples that can lead to the looping error. Scenario 1, workflow pushing back to the same branch. Problem: the workflow lints and formats the code, then pushes the changes back to the main branch, triggering itself again. Scenario 2, pull request workflow merging and triggering a push workflow. Problem: the pull request validation.yml workflow merges the pull request into the main branch, triggering the publish.yml workflow. The publish.yml workflow might then make changes, example updating a version number and pushing, triggering the pull request validation.yml again for the next pull request, perpetuating the cycle. A more subtle variation can occur if the merge pull request action deletes the branch, triggering another workflow to recreate the branch. Scenario 3, workflow triggering itself through a different event. Problem: the comment on issue.yml workflow adds the another label to the issue. Then handle another label.yml acts on this label, adding yet another comment. While the code might appear harmless, the label triggers another workflow, if the labels filter is not carefully configured, creating a possible infinite loop. 4. Mitigation strategies and solutions. Once you've identified the problematic workflow, here's how to resolve the looping issue. 1. Conditional execution and guards. If statements. Use if statements to prevent workflows from running under specific conditions. For example, you might check the commit message or the author of the commit to avoid triggering the workflow on commits made by the workflow itself. Check commit author. Filter based on the commit author. 2. Branch protection rules. Prevent force pushes. Enable branch protection rules to prevent force pushes to the main branch. Force pushes can bypass certain checks and trigger workflows unexpectedly. Require pull request reviews. Require pull request reviews before merging changes into the main branch. This provides an opportunity to manually inspect changes and prevent problematic commits from being introduced. 3. Contextual information and event payload analysis. github.event. Examine the github.event context variable within your workflow. This variable contains detailed information about the triggering event. You can use this information to make more precise decisions about whether to proceed with the workflow. github.context. This is another extremely useful context. The github.context.payload contains all event information. This is where you can find the before and after commit hashes for push events, the pull request number for pull request events, and more. 4. github_token permissions. Reduce permissions. The github_token has broad permissions by default. Grant it only the minimum necessary permissions required for your workflow. You can define custom permissions in the workflow file using the permissions keyword. Use dedicated tokens. If you have a specific operation that pushes back to the repository, consider using a dedicated token with even more restricted permissions just for that operation. Asterisk 5. Workflow exclusion, workflow filters. Asterisk paths filters asterisk use paths and paths ignore filters within the on trigger to specify which files or directories should trigger the workflow. This can prevent the workflow from running when irrelevant files are changed. Asterisk labels filter if using issues, ensure workflows only run on specific labels. Asterisk 6. Avoiding self-triggering commands, use API instead of Git when possible. Asterisk GitHub API asterisk instead of using git commit and git push commands within your workflow, consider using the GitHub API to make changes. The API provides more granular control and can prevent accidental triggering of other workflows. For instance, instead of pushing changes to update a file, use the put/repos/owner/repo/contents/path endpoint to update the file directly. This avoids triggering a new push event. Asterisk 7. Throttle or debounce workflow runs, use with caution. Asterisk avoid overuse asterisk be very cautious when using throttling or debouncing techniques. These can mask underlying problems and potentially delay important workflow runs. Asterisk implement carefully asterisk if necessary. You can implement throttling or debouncing using external services or by creating custom actions that track workflow execution times. Asterisk 8. Environment variables, configuration. Asterisk use environment variables asterisk instead of hard-coding values directly into your workflow files, use environment variables to store configuration settings. This makes it easier to manage and update your workflows. Asterisk 9. Disabling workflows temporarily asterisk asterisk. Asterisk quick fix asterisk if you're struggling to identify the looping workflow, temporarily disable suspicious workflows by commenting out the on trigger or deleting the workflow file. This can help you isolate the problem. Remember to re-enable the workflows once you've resolved the issue. 5. Example, preventing loop with commit author check. Let's revisit the linting and formatting example. Explanation asterisk. 1. The if statement checks if the last commit message matches the commit message used by the workflow to apply linting and formatting changes. 2. If the commit messages match, meaning the last commit was made by this workflow, the git push command is skipped, preventing the workflow from triggering itself again. 6. Advanced debugging techniques. Asterisk logging asterisk add extensive logging to your workflows to track the execution path and identify the exact steps that are triggering the loop. Use echo commands to print out relevant variables and conditions. Asterisk set x, shell debugging add set x at the beginning of a run command to enable shell debugging. This will print out each command as it is executed, which can help you pinpoint the source of the problem. Asterisk GitHub Actions debugging asterisk GitHub Actions provides a built-in debugging feature. Enable debugging to step through your workflow and inspect variables and conditions. You need to add runs on Ubuntu latest and set the step_debug secret. 1. Add the following to your workflow file. 2. In your repository settings, create a new repository secret called step_debug and set the value to true. 3. Run your workflow. Asterisk dry run asterisk before making changes to your workflows, test them in a dry run environment to ensure they behave as expected. You can use tools like Act to run GitHub Actions locally. 7. Checklist to prevent looping commands error 81. To minimize the risk of encountering looping commands causes client request loop error 81. Asterisk review all workflows regularly asterisk periodically review your GitHub Actions workflows to ensure they are still functioning correctly and are not inadvertently causing loops. Use descriptive commit messages. Use clear and descriptive commit messages to make it easier to track changes and identify the source of problems. Test changes thoroughly. Test any changes to your workflows in a dry run environment before deploying them to production. Document your workflows. Document your workflows to explain their purpose, dependencies, and potential risks. Implement alerting. Set up alerts to notify you when a workflow fails or takes longer than expected. Keep workflows simple. Avoid creating overly complex workflows that are difficult to understand and maintain. Break down complex tasks into smaller, more manageable workflows. Follow the principle of least privilege. Grant the github token only the minimum necessary permissions required for each workflow. Be cautious with automated commits. Exercise caution when using automated commits in your workflows. Ensure that you have appropriate safeguards in place to prevent loops. By understanding the causes of this error and implementing the mitigation strategies outlined in this guide, you can effectively prevent and resolve looping commands causes client request loop error 81 and ensure the stability and efficiency of your GitHub Actions workflows. Good luck.